Okay, we'll get started in a couple minutes here. Make sure everyone is here, but get set up. So what we're going to do today is so today we're going to do the review for the midterm. The midterm is going to be on Wednesday. And what we're going to do today is I'm just going to go over everything I like. We're going to take a very large step back and go back to some of the basics all the way through to what's going to be on your exam. So we're not going to do any new material today. Today's going to be a very big review day, just to make sure that even like basic stuff like print and stuff like that you're good on that. Okay, so we'll do that in a few minutes. Go ahead and get set up, and then we'll go ahead and talk about that. Okay, so everyone's here, everyone's set up. Okay, so let's go over the rules of the midterm. So we're streaming here. Perfect. So it's going to be, I didn't already post this, did I? No, okay. So it's going to be 2 programming questions, so you're actually going to have to write code for the exam. So you can use any previous assignments or class examples. I would highly suggest that you try to organize those, you know, and don't just, if you've been saving everything in REPL, don't just depend on REPL. Okay, so if like, I think how to say this. There's gonna, as we do the review, you'll realize that there's gonna be a lot of, there's gonna be like maybe 4 or 5 examples that'll be very helpful in the exam, and maybe focus on those and download those and make sure that you have those ready to go. Okay, so you can use previous assignments or class examples, but otherwise it's gonna be closed. Can't reference the YouTube lectures during class. I've seen people do that before. It's just kind of a waste of time. Just organize beforehand. If you find yourself clicking through lectures, trying to read the captions, that's really not an efficient use of your time. And then otherwise, it's also closed book, closed notes, closed everything, closed internet. Let's say closed. So again, you can use your previous code, but you can't like start bringing books into class. You can't open other websites. The only 2 websites you can use are going to be REPL and Blackboard. If I catch you on any other site, it's going to be automatic 0. The exam must be completed on these computers. So I realize some of you might bring in your own laptops. It must be completed on a school computer. What else? What else? I think that's pretty much it. So as far as the rules of the exam, is everyone clear? Oh, let me also note this. Yeah.
The downloaded files that we have for like our previous assignments and stuff, can we have it on like a flash drive?
Yeah, flash drives are perfectly acceptable. I would actually prefer most people use a flash drive. I just know a lot of people have started to depend on these cloud storage things. The problem with that is that like you could put anything on that cloud storage. Some of those have chat programs. It just gets kind of messy. So it's just like, I just want to keep it simple. Only 2 tabs, only things you can have is Blackboard and REPL. If you do have stuff on some sort of cloud storage system, download it beforehand. But flash drives, that would actually, I think for most people, be my recommended method because it's just a lot simpler. It's like you get to class, just plug in the flash drive, grab your files, and then you're good. Okay, I think that's it. Any other questions? Yeah.
Could we have like multiple REPL tabs open?
Yes, that's fine. Yeah. Now, I would suggest, and I'm going to go over this, try not to rely on REPL too heavily, because what happens is when you start doing your exam, I've seen some people under the time constraints of the exam, so you'll have the full length of the class, and that's all so you have the full length of the class for the exam, that's all we're doing, so you have an hour and 15 minutes for 2 questions. By the way, just so we have like as much time as possible, what I'm going to do is like try to start the exam almost right away, and then when you finish the exam, please leave as quietly as possible, because a lot of times what happens is that like people finish their exam and then they start getting up and asking questions and all this other stuff like that. So just once you've completed the exam, just try to be as quiet as you can for the other people. Okay. Oh, back to what I was talking about. The thing with REPL tabs is that sometimes under these time constraints and pressure that people get their tabs confused and they start messing things up. So what I usually recommend people do is there's going to be like realistically like 5 really pertinent examples to your exam. I would highly suggest putting those in a folder. And then okay, so let me do this. I think that's everything. So let me send that out. So what I would suggest is that all these computers have Notepad++ installed. Or they should, I think anyway. Yeah, there we go, Notepad++. I would suggest having that open with your examples where possible, and then kind of do like a side-by-side thing here, because I've seen people kind of get their like work mixed up, if that makes sense. And like, I don't know how to explain it. It's just, it seems like a minor thing, but it's definitely helped people in the past, where you've just got like your example off to the side, Notepad++, and there's like a very distinct visual boundary between your exam and your notes. And I've just seen too many people just in the middle exam just forget which thing they're working on and start actually modifying code from an old example or something like that. So you're definitely welcome to do that, but I would suggest for most people is that you gather your most important examples, and we'll go over that in a little bit, into like a folder. That way you can reference them and have those opened as Notepad++ tabs. Now, again, if you choose to, you are welcome to use REPL as much as you want for your notes if you have an account, but just keep this in mind. Okay, so any other questions on the rules? Okay, so let's do this. We're going to go all the way back. I want to make sure everyone has a really, really solid understanding of Python, and that like there's nothing that you're forgetting at all. So let's go to, let's open up a new REPL. And let's just spend about, I don't know, maybe 20 minutes just going over really, really basic stuff. Okay. If I want to print something, what function do I use? Print, okay. So I print hello. So anytime you need to print something to the screen, it's print, and then what is this thing in the quote here called? I think I hear some people saying the correct answer. Say it louder. String. So anytime we want to print something to the screen, it's usually going to be some combination of strings and variables. So let's talk about variables. Unlike other languages, we don't declare them ahead of time. What we do is we just say variable name equals something. And whatever the first thing that we assign it, that becomes the data type. The 3 data types that we work with in this class are ints, floats, and strings. String should be obvious. It's just a string of individual characters together, usually meant to be like human readable. And then we've got ints and floats. How would you describe an integer just in plain English? Exactly, positive and negative whole numbers. How would you describe a float? Yeah, now it's not quite a decimal number, but you can think of it like that. We went over an example a long time ago why that's the case. If you're interested, you go back to that lecture. But what else? Okay, so if we want to actually print our grade, There's a bunch of different ways to accomplish this, but the way we've done it in this class is what's called an F string. So we can't just write your grade is grade, because it's, you know, it's not going to know how to interpret that. So what we have to do is we have to surround it with curly braces, but that's still not quite enough. We have to, because this is just a regular string, we have a special kind of string in Python now. This is a recent addition to the language. It's considerably simpler. It's what's called an F string. If I want to get input from a user, there's a special function called input. So let's say, for example, we want to get the student's height. We type in input, enter height. I don't know, 55, whatever units. Inches, maybe, I don't know. And what happens is by calling this function, it prints out this label, this string, enter height, and then it stores it in this variable. Now if we want to actually use that, we can say and then make sure if we're using a variable inside of a string like this, surrounded by curly braces, we make it an F string. We can also do basic arithmetic. So if we said like x equals 5 plus 3 times 2. So what's the result of this? What's 5 plus 3 times 2? So let's go ahead and run this. Oops, yeah, so we still have that thing here. So remember that the order of operations still applies. So it's going to be 3 times 2, which is 6. 5 plus 6 is going to be 11. It didn't do 5 plus 3, which is 8, times 2, which would be 16. It didn't do that. So just like in algebra, we have our order of operations. Now, anytime we see a single equal sign, this is what's called the assignment operator, as opposed to our equality operator. Okay, so this is assignment, and basically what we're doing is we're taking the stuff over here, and we're assigning it over here. Now, we can actually reassign things. So let's say, for example, we say x is equal to x plus 1, and then we print x. I'm gonna comment this other stuff out. It's just kind of getting in the way now. Oops. Remember the way this is evaluated. So at this point on this line right here, x is equal to 11. Normally the code runs from top to bottom, left to right. But here, in this case, it runs a little bit maybe out of order from your intuition. What it does is evaluates the right-hand side of the equal sign first. So it takes 11 plus 1, which is 12, and then it stores it over here. And that's why we have this. Okay. And then let's briefly go over if statements. I'm just gonna use one REPL. This is just like a reminder stuff, and then we'll go into more specific examples. So let's say age is 55. So what data type By assigning age equals 55, what data type is this? Integer, right? Oops. Kind of a stupid example, but so these two equal signs, this is called equality. We have assignment, the assignment operator. This is an example of that, one equal sign, two equal signs. This is called equality. We're checking to see if the thing on the left-hand side is equal to the thing on the right-hand side. In this case, it should be fairly obvious because we actually we just created that line of code. In what instance, so we can use equality on strings and ints, so the three basic data types that we've worked with so far. What data type of the three that we've worked with so far is it not generally a good idea to use it on? Float. Does anybody remember why? Yeah, it's like the precision's kind of like not exactly what you'd expect. If you remember, we did that example. Remember, we did 0.1 plus 0.2, and then we checked to see if the result was equal to 0.3, but it turned out it was false. Okay, so just be very, very, very careful using the equality operator with floats. Now the language will still let you. It'll still let you do that. But the problem is that it can cause these very, very, very subtle bugs. So when you're using the equality for the data types we know right now, just stick to ints and strings. Okay, so here we had our if. Remember that so remember this indentation. This indentation, I think, is throwing a lot of people off. Remember that we indent. I think I went through this last time. Does anybody see how to save this? Like if I set it to 4. I think the language standard generally is 4. It's like I set it, and then how do I save it?
For me, you just have to sign in, and it loads in a setting.
Oh.
Press the cog wheel again, and it should save it.
That's like one of the settings that you. So right now this is still 2. Maybe it's any new code.
Yeah, I think so.
Oh, there we go. Okay, perfect. By the way, so you might want to do that. Set it to 4. The language standard is 4. I don't know why REPL defaults it to 2. There's this big joke within. I don't know if it's so much a joke or people really do get angry. Spaces versus tabs. I personally, I prefer tabs a little bit more, but personally I don't care that much. But in Python, the language standard is 4 spaces, and whether you agree with that or not, it's generally a good idea to try to stick to the language standard and not what you think is better. You know what I mean? Because what's going to happen is other people are going to have to read your code at some point. But anyway, this makes it a little bit more readable. I think maybe 4 spaces. And anytime we so the language is whitespace dependent versus a language like C++ where it's independent. It doesn't matter how many times you hit the tab, space, enter, any of those whitespace characters. The code's going to essentially, it's going to look for the semicolon at the end of the line. However, with Python, the way it works is that it's whitespace dependent. So whitespace means certain things. In this case, it's like we're saying that this is a code block. Like in C++, we might be able to surround this with curly braces to let you know where the code starts, the if block. Here we use tabs. Now, where people run into issues is something like this. So say, for example, you think you're outside of the if statement because you hit the enter key a few times, and I've run into this. Maybe with 4 spaces, it's a little bit more apparent. With 2, I could see if you have a smaller font and you're kind of working kind of quickly, missing it. I think I've missed it a couple times in class myself with 2 spaces. You have to be careful of this because this is still here. Now, REPL gives you this little visual cue. Notice this line that once you indent, notice how that line got shorter because it's saying that this one line of code is part of this code block right here. Now we have our ifs, and then let's do this. So we have our ifs by themselves, and then we can have an if else. We can have an if elif. And remember, it's not like other languages where it's the full words else if. It's elif. So elif. So if we were to change this, so make sure you understand all those little operators. Again, this should be review. I only want to do a few more minutes of this. I want to get to your exams. Basically going to be assignment 3 and 4, and I want to go ahead and solve those problems. I just want to make sure everyone's good on the basics, on the fundamentals. Now we could have had an else statement at the end, and just had something generic like something went terribly wrong. So let's go ahead and do that. We can have a catch-all. In this case, I don't know. It doesn't seem like something wrong could, something could happen, but just in case. Okay, so if we reach the else statement, something really weird must have happened. Because this is an integer. Okay, so I'm just going to use one REPL because these are kind of short, pointless examples just to remind you of the different terminology and operators and stuff like that. Let's keep on going here. We had, remember our menu-based system? So now don't think of in like individual little tiny things of code. Think of like larger reusable common tasks, like a menu system. So what I might do is I might say, like for, let's say liters to gallons and gallons to liters. I'd say press 1 for liters to gallons. Gallons to liters. And then choice is equal to input choice So at this point, our choice is stored in this variable called choice. What data type is it? String. So there's a couple different things you can do. what we can do is we can surround this whole thing by that function int, or we can say that choice is equal to the choice that they entered in, but it's actually an integer. Okay. Now you don't have to do this, but just remember it's always gonna input. And let's actually not do that. Strings are fine for this. Okay, but now if we wanted to, so do I do if choice is equal to 1? Yes or no? Is that correct, the way I wrote it? So I got rid of that. I got rid of line 28. So the data type is a string. Is line number 29 correct? No. What does it need to be instead? It's the number 1 as a string. And by the way, we'll use this sometimes in class. This is a placeholder, this keyword pass. It just means that I'm going to put in some code here later. You're going to see these little patterns all the time. Okay, so again, don't think of like you're solving every problem from scratch. Think back and say, okay, well, this problem obviously needs a menu system. So let me build out the menu system. Things like that, okay? Next thing might be, okay, I might need to do some sort of calculation. Well, I'm probably not doing the calculation from scratch. Let me look at the example and see kind of a similar calculation that I've done previously. Okay, so any questions on any of the terminology or any of the basics that we've covered so far? So let's go ahead and we'll come back to functions and other things, but let's very quickly solve assignment number 3. So what I would generally suggest people do is that, like, on your exam, take this. So I'm going to go ahead and open up a new REPL here. Resources. And kind of paste it in here somewhere. What you can actually do is these, it's not the greatest way to do it, but you can do these triple quotes right here. It's technically not a multi-line comment, but it does the job. It's not something you'd probably want to do in production code, but this is an exam and I'm telling you it's okay, so it's okay to do for the exam. Okay, so I'm going to go through this program a little bit quick because we've gone over similar examples, but just so you have the correct answer if any of you didn't quite get this one completely correct. So create a program which calculates shipping costs. First you're going to ask for the size in pounds and then the speed of delivery. Slow, medium, or fast. And the idea is that we have 2 sets of calculations. And really the program can be broken down into 2 parts. Now, knowing functions, this program could probably actually be solved a little bit better using functions, but let's just kind of solve it like how we solved it, knowing the knowledge at that point in the course. I don't want to make any major shifts, you know what I mean? Like, even though we learned something later, to go back and, let's just kind of keep it to where using the knowledge we knew at that point in the class. Okay, so there's going to be 2 parts. The first part is going to be calculating what I'll call the base rate. So we know we're going to have the user enter some sort of weight. So let's say weight is equal to, we're going to ask the user for the weight. But now what data type is the weight right now? There's only 3 choices: int, float, or string. String. What do we probably want it to be instead? Float. Yeah, so we'll say that weight is equal to float weight. And then we've got a little shipping rate table here. Let's go ahead and implement that. And remember, like I said, this is actually, technically you can't, you know, there's a lot of ambiguities in this. And so the reason I did this is because it's very common. This is how you get requirements. You get requirements where it's like, it looks clear, and then you go back and actually start programming. You're like, wait a minute, there's some things about this, you know, there's some overlap here. I don't know how to handle this. And so in this case, I kind of said, make the executive decision on that last little like 1 cent. But in real life, you'd go back and you'd ask them to clarify. But for this example, I did that on purpose just so you saw that it's not uncommon to get requirements like that. So we're going to say that if the weight is greater than 0, and remember we had this keyword and. If we're checking for 2 things, both these things need to be true. If the weight is greater than 0, and we can't say less than 1, we have to say and weight is less than 1. So here we'll say up to but not including 1. We'll do the calculation in a little bit. For right now, let's just write the keyword pass. If I can't do this, correct? Because what's the problem with this? I've got this little gap exactly at 1. So what do I have to do instead? What's that? Exactly, yeah, greater than or equal to. And we'll just kind of keep this symmetric and just say and weight is less than, my rate table over here says 3 pounds. And we'll just fill this in right now with that. If, and again, we don't want a gap. We don't want just greater than 3. We want greater than or equal to 3 and then this one you can kind of make your own call on it if you want to include 10 or not. Let's just go ahead and include it. On the exam, I wouldn't really look at that level of detail. So on the exam, a good idea is do things like this. Set up some skeleton code. You know, here we've got the keyword pass a bunch of times. Pass is just like a placeholder. Does it make sense why we would need this? I guess I need to make an account because it keeps on setting me back to 2. So we don't have much, but at least we can test it. What's the one thing that we can test here and get some sort of feedback? What's that? Yeah, so we can enter a weight, and then what other thing, like say for example, if I enter in an invalid weight, that should give me some feedback. Everything else, I haven't implemented the actual logic. So if I enter in something that should be a valid weight, but that's fine. So now we go back up here and let's go ahead and just quickly implement this rate table. And let's do one more thing. I think we cheated on this, right? I said you could do sys.exit. Usually you want to import your imports at the top, but actually let's go ahead and do that. Let's go ahead at the top of the file. We're gonna.
That was very uncomfortable for you.
Yeah. It is actually okay sometimes to do that in the middle of code. If it's code that doesn't execute that often, rather than doing all your imports, if it's a rare import and that import might slow the program startup speed down, then sometimes it is okay to do imports in the middle of code. So at the top of the code here, we imported sys, and if it's an invalid weight, just exit the program. Then what that lets us do is So let's go ahead and implement this now. It's we're going to say price is equal to the weight times, in this case it's 5, and then we can just copy and paste from there. 5, 3, 1. Now, unlike other languages where you might have needed to declare price up here, you can actually do this in here. The scoping is a little bit different. There's like a very technical name for the different types of scoping. I can't remember what style this is, but anyway, price is valid here. So we can do just the check. We can say, as an F string, we can say base price is price. Now let's just quickly spot check this. Okay. Other languages, you can't really do things like this. Like you couldn't declare a variable inside of an if statement. You don't end up with scoping issues, but here we can do this. And this sys.exit, by the way, this is just so if we enter in an invalid weight, it doesn't say invalid weight and then base price. It just kind of, the program dies. Okay, and then now let's do the second part. Again, we're going to have a menu-based system. Here we can just say that like this is going to be the shipping speed section. Say available shipping speeds maybe. And then, if you remember the basic idea that slow would be ground, medium might be 2-day, and then fast might be overnight. And then here we could be just very generic and say choice. Maybe you would want to say speed choice or something like that, or speed. I'll just stick with our choice variable. And then we'll say input choice, just so we're still following that pattern. And now remember, choice is a string, so we have to say, we can't just say if choice is equal to 1. We have to surround it in double quotes. Pass L if choice is equal to 2. Pass L if choice 3. Pass else. Same logic up here. So I'm just going to copy and paste. By the way, be very, very careful copying and pasting code. Notice how when I copied and pasted this, this is not correct. I don't even think this will compile. Yeah, see, it's saying something weird's going on here. So always keep that in mind. Python forces you to write readable code as far as like indentation and stuff. I've just seen a lot of student code from COP2030 where like the spacing is all crazy and the program runs because technically, you know, it's whitespace independent. And I think a lot of times when people do that, once you get into your kind of next level stuff like Python, it's a very difficult habit to break because you've just gotten so used to just writing the whitespace however, and then now when you have to actually pay attention to it a little bit, it's not going to be invalid weight, it's going to be invalid choice. And that, again, that should be enough to test. So I can enter in a weight of 2, calculate the base price, but if I enter in a choice of 5. Perfect. Okay. So let's go ahead and fill this in. This should be fairly straightforward. We can reuse the price variable. In this case, I would say just reuse it, unless we know we're going to need that base price for something else again. If we know like in this case we're not going to, we can just say price is equal to what was it? 1, 1.1, 1.5. This may seem like a useless thing, but it's good sometimes to have these placeholders, because in reality you wouldn't actually put the pricing structure in the program. Most likely would read this from a text file or a database or a web service or something like that. And you might decide to have like a coupon code or a sale or something like that. And if you had left this whole logic out, you wouldn't just be able to change that value from 1.0 to something else. You would actually have to go back in the program and add additional logic. Oh, and then final thing is we have to, I guess we'll call it total price. Any questions on that? Now, because I'm already telling you that these 2 homework assignments, or class assignments, or whatever you want to call them, these are going to be, like, your 2 exam questions are going to be based off of this. I would highly suggest, if you're going to pick a few examples from REPL to put inside of Notepad++, these would probably be good choices. Okay, does anybody need me to scroll to a piece of code, or does everyone get everything? Okay, so let's go back to one of these kind of scratchpad REPLs again. Let's just go over for loops, lists, and functions. I want to spend a few minutes on that, and then that should take us to the end of class. Let's go to resources, REPL. Try this again. There we go. So we have this data structure called a list. And a variable can only hold one thing, like a single just regular variable. Sometimes we'll use the term scalar variable. It can hold a value, like a single string, like a name, or 5.5, or -10. It can only hold one value. But a list can hold a list of values, multiple values. So for anybody who remembers arrays from COP2030, the closest thing is going to be arrays. But underneath, the actual technical internals of it, it's a little bit different. But you can sort of think about it as an array. Now, it's a dynamic data structure, so you can actually expand it versus like an array where you actually have to, at compile time, create that block of memory. But anyway. So let's create a simple list. Let's say grades. The particular numbers don't really matter that much. Just put in 4 grades. And now if we were to print grades, notice that it doesn't print like a regular variable. It has these square brackets around it. These square brackets mean that it's a list, and we comma separate the list, so each individual value inside of the list basically this is what we call an element of the list. Now if I wanted to access an individual element of the list, it starts at, it's 0 indexed, so I'd say like grades 0, and that actually gives me the individual value of that. Now if you remember for loops from COP2030, we do our for loops a little bit different It's closer to like what's called in other languages like a for each loop. And if we want to iterate over all of the grades, what we do is we say for grade in grades. I'll just put pass for now. Actually, just leave it blank. We'll fill in the code in a second. So for grade and grades, some people ask me if there was like something special about grade. No, you could just use X if you wanted to. So you could just use X or whatever, but a very common code convention is like you have the plural version of the list, so grades with an S, and then the singular version. And that just makes it a little bit easier to track code. Remember that code is like a living thing as far as it's very rare that you write a few lines of code and never do anything with it ever again. It's going to need to be maintained. Somebody else is going to have to look at it. They might get irritated at you that you like used some weird variable name or something like that. So try to get into good code conventions, make your code readable. This is one of those good conventions is that you use for singular in plural. And then that way, if you need to reference grades, you know that it's a list because it's plural. Grade is the singular version. That's the element of the list that you're working with. Okay. And what that does is that each time through the loop, that assigns grade to that particular grade. So it's going to go through these one at a time. It's going to go here, and grab this one, and then grab this one, and grab this one. What it does is each time through, it assigns that value to grade, and it makes it available for us to use. Now let's do this very briefly. Let's put our code here. So I want to talk about functions. Now you remember a function, it's a reusable piece of code. The analogy I gave you is that it's like this box that it's got inputs and it's got outputs. And on the what we do is we want to feed it inputs. It does some calculations or something interesting, and on the other side we get back outputs. Now that's not always the case, but let's work with that simplified model for now. So let's make a yeah.
Does Python care where you define your functions?
Yes. So and that causes problems. In general, I always like to define them on top. Now I think it can read ahead. It can do other things, but let's say for example, let's do this. I'm pretty sure I'm so in the habit of defining them at the top that I think, well, let's try a few things. So let's do this. So let's make a function called is_passing. And we'll be very generic. No, let's not. Let's say grade. Let's be good here. Remember we talked about scoping. So this grade is scoped to this function right here. And it'll be a very simple function. It'll just say if grade is greater than I guess this 60, return true with a capital T. Remember we talked about booleans a long time ago. Else return false. And so rather than printing the grade, let's do this. Let's print, we want to know if that's a passing grade or not. So we'll say print grade, and then we'll do this. We'll just print the end result because we're kind of running a little low on time here. Oh, and then we had this. I can get rid of this. So in this case, all the grades were passing grades. Now, remember that we had a special function. If I wanted to extend a list, I could do grades.append. And let's say, for example, somebody got a 40. That should print false, and that's going to append at the end of the list. So perfect. just out of curiosity, I'm pretty sure this shouldn't work, but some, you know, I'm wrong a lot. So yeah. So basically what happens is I'm just so in the habit of defining all my functions at the top that it usually you can get around it. Yeah, unfortunately it's not like a language like Java or something where it knows to look like it pre-compiles or something like that. Since it's a scripting language, it reads it from top to bottom as it's going. So okay, so everyone's good with lists, for loops, and functions. Let's take that information. Let's go ahead and solve the next problem. So I'm going to open up a new REPL here. So assignment number 4. And again, for your exam, go ahead and put it in this triple quote right here. That way you can reference it without having to go back and forth between tabs. So I give you a list, and then I say, create a program which finds the average of this list. But you can't just do that. You have to create a version that uses functions. So let's do this. Let's first create the version that doesn't use functions. Okay, so I'm going to copy it, and we'll just be very vague. We'll just call this numbers. And so we're going to create, if you remember, we went over this algorithm. Is basically, we set the total to 0. Each time through, we say for number in numbers. And then we say the total is equal to the old total plus the number I'm on right now. Now there's even one more shortcut. If you remember, we used the plus equals. But after the midterm, I'll start using some of those syntactic sugar type things a little bit more. Right now, I'm just going to write it like this, just to be super clear what's going on. It's taking the old total, adding the number that we're on, getting a new total, and putting that here. And so at the end, by the way, I'm going to call this AVG because we end up with these name clashes sometimes where like our function name, I should have addressed this earlier. Our function name is called average, so we can't use the full word average, so we'll just use the abbreviation. Or maybe let's even do this. Let's call it result, because we know that the result is the average. So what we do is that we take the total, and what do we divide it by? What do I put here? I can't just do this. This is not a good idea, correct? What should I do instead? Exactly. Because we could decide to append this or add other numbers. We don't want to change code in multiple spots because it makes the code fragile. So we did this part in class. This was just the algorithm to find the average. And the next part was to put it inside of a function. So your first attempt at it might be something as simple as like this. Kind of works, right? What's wrong with this? Exactly. Since we've hard-coded numbers, is this reusable if somebody wants to use this with other numbers? No. What they have to actually do is they have to go inside of your function and change it, and in reality that doesn't happen. The idea is that think about it again. All this stuff on the inside is the box. You don't want people looking on inside the box to see what's going on. Even if you wrote the function, you don't want to have to change the function each time. You know, it becomes, defeats the whole purpose. So you want it to be reusable. So what we're going to do is that we're going to say, okay, let's go ahead and define numbers over here. And now what we're going to do is that we're going to take in as an argument, as an input, we're going to say, okay, give me the numbers that you want to do the calculation on. Remember, this is the blueprint. This is the actual execution of that. Remember how these code blocks work, is that basically it's like from here to here, that's our code block because we've indented. And this is just our blueprint. It doesn't actually run until we call it. Here I'm actually calling it. So we're close. So now we're defining our list of numbers. We're going to feed it into our function. But we're missing one last thing. Why is it not a good idea to print the result inside of the function?
Yeah, because not all interfaces are through console.
Yeah, exactly. It'd be kind of pointless that if I could only use this if, you know, I'm returning it to a user. I might be returning it to a non-console program like a web interface. I might just be returning it to internally within the program. If I'm like writing a game or something like that, and I want a function that finds the average, and then I want to do something with the average, something else that the user might not see, that's the whole point. So in general, we want to have a very clearly defined input. Here we do have that, where we take in a list of numbers, and then a very clearly defined output. We don't have that. Here we're just printing the result. So what do we want to do instead of print result? We use this special keyword return. And remember I told you the stuff that comes out the other side of the box? Anytime we call this special keyword here return, that's what's happening. So we've called the function. It's returning a result, but we're not doing anything with it. So let's go ahead and then just as an F string. Notice that you can have the same program with the same basic external effects, like the final program always wrote average is this, but we went through and we refactored it and designed it a little bit better so that it's got a very clearly defined input and clearly defined output, and it's now reusable. A lot of people get upset because they'll write programs and, well, it gets the job done, but the problem is that, again, you don't write code just once and then leave it forever. Code changes. Even if you did write a little piece of code and left it forever, it's like you might want to reuse that code in other spots. So what are you going to do? Copy and paste, So we get into this idea that we want to design the code in a very organized way, because organized code is easier to maintain, has less bugs, costs less to maintain because you're going to spend less time like reading over code, not understanding what it does. So for the most part, just solving the problem isn't enough. A lot of times it's a good first step, and then you go back and reorganize your code, but you can't just stop at that first step. You have to, after you solve the problem, you have to go back and organize it in a reasonable manner. Okay. So that's pretty much it, right? I think that's all that question asked for. Yeah, we used the len function. Okay. So I would highly suggest referencing these two. Okay, make sure that you know these backwards and forwards. What I would actually suggest was, so obviously on the exam you can use your the examples. I would suggest try to write these from scratch and just see how far you can get without having to reference anything. Just as, practice for yourself. Just go back to these problems and just say, I'm not going to look at any other code. I'm just going to paste this in here and see if I can rewrite the program. Okay? And obviously try not to memorize it. Try to actually go through the actual process. Okay, so everyone's clear on the rules. Everyone knows the exam is next class. I really want to start as close to 11 o'clock as possible to give you the full hour and 15 minutes as possible. Again, when you leave, so that's all we're going to do that day is the exam. When you leave, please leave quietly. And I think that's it. Any other last minute questions? Okay, so if anything comes up between now and next class, go ahead and email me. But if there's no other last minute questions, good luck studying and good luck on the exam.